Welcome back to another video on double A learning. Today we're going to be sticking with a math topic and of calculus, and that being of limits. So this is probably taught in like a calculus, introductory calculus 1 class, or if you're in high school like calculus AB. So yeah, this topic is really important. It's like a fundamental. So before we get into it, let's define what is a limit. Okay, so a limit in calculus describes behavior of given function given the input approaches certain value. Okay, so what does this mean? So basically what a limit tells us is if we have a simple graph like this one I'm going to draw. Let's draw a proper graph here. 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5, 6, 7. Okay, and let's just draw a line. Let's redo that. Okay, that's better. And then let's say we have this value right here. What a limit allows us to do is find the f of x value where we're approaching that point. So the limit formula can be written like this. So the limit of x of a of f of x is equal to L. Okay, so what this means is as the x of a, as x approaches a, f of x gets closer to L. Okay, this is important to know because we're going to be writing most of our things in this function notation. So let's just give the example in this case right here. We have the limit as x approaches 1 because the value right here in the dot is 1. Then f of x equals what? Alright, we need to find what this is equal to. So when using limits, you have to make sure that the right side approaches the same value as the left side and vice versa. So from this we can both see that the left side is approaching 1 and the right side is approaching 1, so we know the answer for this one would just be 1. So I'm going to go more in detail about how these left side and right side limits can be written as. So let's do that in the next page. Okay, so limits can be seen as being one-sided. So the limit notation that I had originally wrote, the limit as x approaches a of f of x equals L. This function notation just shows as long as the left and right side are met, they're equal. But sometimes, maybe on like your guys' exam or homework sheet you guys have, you could see the limit notation written as like this. The limit as x approaches a, and then a minus sign here of f of x. Or you could see it written as limit as x approaches a, and then a plus sign of f of x. So what this basically means is this one is talking about the limit, the left-sided limit. So if we drew a simple graph here, it's our graph, and we just have this point. The left-sided limit we were just talking about as this part approaches. Now this can be really important in some situations where like the limit is not straight or like linear or quadratic or whatever, continuous. It's not continuous. So I'll show you guys an example of those in a bit. But yeah, first get familiar with this topic. So then the limit as x approaches a from the plus over the plus, that shows the right side. And that would be seen maybe something like this. So you have this point again, and we'll just be approaching from the right side. So if those values, if these two are equal to one another, then you can prove this one up here is true. But if one of them are different from the other, you write the limit does not exist. So if, let's say, the limit as x approaches a from the right side is 5 and the limit as x approaches a from the left side is 3, then the overall limit doesn't equal each other. 3 and 5 don't equal each other. So let's show some examples of where that could happen. I'm going to draw this graph and I want you guys to think what's wrong with it. So let's just label the points here. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 3, 4, 5. Okay. So let's just draw this graph right here. So we're gonna have a point there, and a graph like that, and then we're gonna have a point there, and a graph like that. Okay. This graph is obviously not continuous, and this is actually one of the examples of the discontinuities you guys need to know. So this one is called a jump discontinuity. I'm just gonna write disc for short. So this is one of the discontinuities where, okay, let's see, we have the x value right here, so let's just write this out. The limit as x approaches -1 from the left side, that would be that of f of x, that would be -1. And the limit as x approaches -1 from the right side of f of x, again, that would be right here because it's the right side, and the left side would be right here. This right side would be +1. So as you can see, we get two different values. -1 does not equal 1. So the limit as x approaches -1 of f of x, it does not exist. So sometimes it can be like this and could be a little tricky if you guys are given, but make sure if you guys are given two different values of the left and right side, you know that it does not exist. Let's go over the discontinuities now. So there are three main ones that you guys have to know. And the jump discontinuity, which I talked about earlier, which looks something like this. Then there's the removable discontinuity, which looks like if you just have a linear graph, but there's a hole in the point, and then the point is really up there. And then you have the infinite discontinuity, where you have like a vertical or horizontal asymptote that's making the function go on forever. It looks something like that. And then there's another example where the graph keeps on oscillating. So it just gets like really closer and closer to that 0 point maybe right there. So that's also something you guys need to know. Like if depending on where the point is, it can cause a discontinuity. So these are the main discontinuities you guys should know. And yeah, let's go into some other ways that you can solve for limits besides graph. So limits have their own rules, just like derivatives, just like integrals, they have their own rules as well. So these are like the main rules that you guys need to know. So first one is the sum rule. So the sum rule is basically written like this. The limit as x approaches a of f of x plus z of x, that is equal to b plus c. And just so you guys know what b and c are, the limit as x approaches a of f of x is equal to b, and the limit as x approaches a of z of x is equal to c. So the sum rule is basically saying for limits you can just add them together, kind of. Okay, so now let's look at the difference rule. So the sum rule is just adding them together. The difference rule probably sounds predictable, you just subtract them together. So the limit as x approaches a of f of x minus c of x, and then is equal to b minus c. These can be like helpful when you have more larger limits that you may need to solve for with different functions in them. So the next one is the constant rule. I'm just going to write that as con. And that's the limit as x approaches a of k f of x equaling k times b. Okay, the next one is the product rule. I'm just going to write as pro. And that's written as limit as x approaches a of f of x times z of x, and that's equal to b times c. And then we have one more, the quotient rule for limits. I'm just going to write as quo. And that's the limit as x approaches a of f of x divided by z of x is equal to b divided by c. These are like the main rules you guys would need to know for limits if you guys need to ever solve for them. But yeah, let's get into some solving limits using algebraically and using a table. Okay, so the first example is going to be algebraically. We're just going to label it 1. And that's going to be the limit as x approaches 2 of x squared minus 4 divided by x minus 2. Okay, first thing, whenever you have to solve a limit algebraically, is plug in the number here. So you have 2. Let's plug in 2 to the value where x's are. So that would be 2 squared minus 4 divided by 2 minus 2. That's equal to 0 over 0. When you're solving for limits and you get 0 over 0, that's known as an indeterminate form. That should not happen. That means you did something wrong. So in this case, you can let's first factor out this part right here. So again, just always start with limits by plugging in. You sometimes never know it can work, so it's always important to check. So let's plug this. Let's write limit as x approaches 2, and let's factor this out. So instead of x squared minus 4, we know that can actually be written as x minus 2 and x plus 2. Okay, so that becomes x minus 2 and then x plus 2 divided by x minus 2. Okay, now this becomes more simpler because using our algebra skills, we know that this can factor out. These two cancel out, and that becomes limit as x approaches 2 of x plus 2. And now all we have to do is plug that 2 back in, because this one satisfies the equation. So this just becomes 2 plus 2, and that's equal to 4. And that would be the answer for this limit. So just remember that a limit cannot be be 0 divided by 0, because that's known as being in indeterminate form. So always there's loopholes to usually go around that limit. And there's a rule which I'm not going to go into in this video, but I can create a separate video if you guys want to. That's the L'Hopital's rule. L'Hopital rule. And basically, this is a more easier way for solving these indeterminate limits. So if you guys want a video, just let me know about that. Okay, let's go over tables now. So let's say we're given this table right here. We're going to label this example 2. So let's say we're given the table right here, x, and then we have f of x. And then we have values of 1.9, 1.99, 1.999, 2.001, 2.01, and then 2.1. And we want to find these f of x values. And I'll just label them as question marks for now. Okay, so, and we're given the same equation that we had originally, the same function, the limit as x approaches 2 of f of x. We want to find that, what's that equal to? And we know that f of x is equal to x squared minus 4 divided by x minus 2. So that's our function, and we want to find what x approaches 2 is. We can see from the table that we have values that are really close to 2. So all we have to do is plug in each of these values into this equation right here. So plug in 1.9 and solve for that, plug in 1.99, solve for that, and then you'll get the value, you'll find the limit as f of x will be really close to a certain value. So what you would have to do is, I already did the math, the calculator math, so I'm just going to write out the numbers. So f of 1.9, that's equal to 3.9, and then f of 1.99, that's equal to 3.99, and then f of 1.999, that's equal to 3.999, and then f of 2.001, that's equal to 4.001, and then f of 2.01, that's equal to 4. Oh, let me rewrite that better. 4.01, and then f of 2.1, that's equal to 4.1. Okay, so just from these values, we find that the f of x value is it's inching closer to 4. So here it's getting bigger as you get closer to 2 right here, and here it's getting smaller as you get closer to 2 from the left and from the right. So we know that the value of the question mark will be 4. So that's how you solve it with. That's how you would solve it with tables, and yeah. So that's gonna be it for this video. If you guys need more practice, there's gonna be a practice worksheet again in the comments. But yeah, thank you so much.